Hi everyone, this video is going to be the first of a couple of videos that are focused on immunizations. So this PowerPoint is a bit more detailed and in-depth than you're actually going to be quizzed or assessed on, but that's just because the current climate of the world, I want you to have as much information as possible about vaccines. So let's go ahead and get started. So here are a few key terms, but I want to add two more to this, but let's go through this list first. So variolation is a term we've already discussed briefly when we talked about Jenner back in the day. And variolation is what Jenner did when he inoculated cowpox into a boy. And in doing so, the child got cowpox, which you can actually see on the bottom right of the screen. But that immune response was enough to protect him against smallpox, which was much more life-threatening. And so that actually led to modern day vaccines, which is where we suspend either the entire organism or part of an organism and introduce it into the body in order to induce an immune response. And what we're hoping will happen with vaccine is that it will confer a long-lasting immunity, although that's not always the case. But no matter what, these vaccines are inducing a primary immune response because we want this to be the first time somebody is encountering this pathogen, right? Because our vaccines are normally against very dangerous pathogens. And so through a vaccine, it's a safe way for the body to be introduced to them and build up immunity. That way, if they encounter the full-fledged dangerous version of the pathogen in the future, they will already be protected. And then another term that's also going to come up again in our epidemiology discussion is herd immunity. And that is when the vast majority of a population is immune and therefore protects the few susceptible people that may not have been vaccinated. So we'll come back to this idea later. Now, the additional terms that I want on here is immunization and vaccination, okay, because a lot of times people use them interchangeably, even though they should not. So the term immunization is what's used when we're talking about making someone immune to something, okay? So that means that the individual has produced antibodies and memory cells, which we talked about during our acquired immune discussion. And these antibodies and memory cells will actually protect the individual from future disease. Okay, so a person can actually become immune if they get the disease and overcome it, or artificially through vaccination. But like I said, not all vaccines confer lifelong immunity. Okay, so you may not be immune forever. So the term vaccination is simply referring to artificially injecting somebody with, again, the entire or part of a microorganism in order to prevent or even treat infectious disease. However, like I just mentioned, even though the purpose of vaccination is to allow that person to develop immunity, vaccination does not guarantee immunity. Okay, vaccines are not 100% effective for a variety of reasons. Sometimes it has to do with the preparation of the vaccine, depending on the pathogen, especially if it's like a virus, maybe it mutates so that the vaccine isn't effective. We've started to see that with COVID. And sometimes just the immune response of the individual person receiving the vaccine just isn't as strong or intense as it is for somebody else, okay? So remember that vaccination is a form of active immunity. Okay, so that is where the person is actively producing their own antibodies. Okay, so this is an artificially acquired form of active immunity. Okay, but it is still active because our antibodies are being made by our immune system in response to the vaccination. Okay, all right, so now let's talk about two of the types of vaccines, and then we'll focus on the other ones in a different video. So we first have live attenuated vaccines. And an attenuated vaccine means there is a live organism, a virus or bacteria, that has been weakened. And it is that weakened virus that actually gets injected into the person. And because that organism is alive, it is going to replicate and stimulate our natural immune responses. Okay, so this is going to mimic an actual infection. Okay, and that's why this is one of the stronger forms of immunity that we can get when we use an attenuated vaccine. Okay, we say it is the best teacher of the immune system, but this kind of vaccine isn't always possible depending on what the pathogen is. Okay, so again, the goal is to establish a subclinical infection to where you are going to get some signs and symptoms of the disease, possibly, but you're not going to get near as sick as you would be if you encountered this pathogen, naturally in the wild. So how can we attenuate pathogens? Well, we can use genetic manipulation. So maybe we're going to make it so that the organism no longer has key virulence factors. Sometimes we can actually culture or grow the organism in the lab for a very long period of time, which tends to weaken the pathogen. Sometimes we can culture it in an unnatural host or environment, and that's going to actually promote mutations that are going to decrease its virulence. Okay, but still it's going to establish an active infection. Okay, so again, it's a more comprehensive immune response than the remaining vaccines that we're going to talk about, because again, it's going to activate both the humoral and cellular immune responses. And because that means we're going to develop those memory cells, we're going to have a long-lasting immunity towards these. Now, of course, there are disadvantages with everything. And when it comes to our live attenuated vaccines, sometimes challenges are going to be like long-term transport and storage. As I mentioned before, there's also the potential that a patient is going to develop some of those signs and symptoms related to the disease. There is also a very small risk that this attenuated pathogen will revert back to its full virulent form. And so that is a risk associated with these. We actually saw this with polio back in the day. So some common examples of attenuated vaccines are going to be the MMR vaccine, which is against measles, mumps, and rubella, the Viravax vaccine, which targets varicella zoster virus, which is what causes the chicken pox. And then there's also one for shingles as well. And there's many others. They're listed in the lecture notes, but those are some of the ones that you may have heard of previously. All right, so next up is going to be our inactivated or killed vaccines. And these are going to be vaccines that have the entire pathogen in it, but that pathogen has been killed or inactivated, whether that be by chemicals or heat or radiation. So because it's inactivated or killed, right, it's not going to be able to replicate in the body, which means you're not going to get near as strong of an immune response. And actually, for this type of vaccine to really be effective, the inactivation process can't affect the actual structural integrity of the antigen, right? Because it's the presence of that antigen that actually activates our immune response. Okay, so like I said, there's no active infection that's going to occur because this organism is dead. And so the immune response will be weaker and much less comprehensive compared to our live attenuated vaccines. And typically, as you can see on the slide, only humoral immunity is going to be activated. Okay, and in this case, the pathogen cannot be transmitted to other individuals, which is good. These inactivated vaccines also typically require higher doses and multiple boosters, which are some of the disadvantages to this type of virus. However, an advantage is going to be much higher stability, in terms of long-term storage. They're easier to transport, right? Because we're trying to keep something alive. But also there's no risk of, a person that gets the vaccine getting, any type of signs or symptoms or active infection. Okay, so now that doesn't mean there aren't ever any side effects, right? There's pretty much side effects all the time, but you're not going to get a full-blown, infection because the organism is dead. All right, y'all, that is going to be it for this video.